Hello everyone, today we'll be solving the problem destroy it, right? So this was asked in the Codeforces round 565 division 3, the last problem, right? So it is hard, actually literally hard. So it's rated 2100, one of the difficult questions that I have solved, basically. I'll not lie. So you can just go through the question. I'll just summarize the question so that it will be easier for us to solve the problem, right? So just give me a second, 1 second. Yeah, so what the question states here, we have n turns. Just remember, we have n turns basically, right? So on the ith turn we get ki cards, right? So on the ith turn, what we get, we get k cards basically. Ki, this is represented by ki basically, k cards. So each card has cost C in 1 2 3 and damage D. Again, each card has this one, cost C, and this one, each card has cost C, sorry, not and, in 1 2 3 basically. Just remember this one, in cost C in 1 2 3 and damage 4, and damage 4. Just remember this, damage 4, right? Sorry, what did I say? Damage 4? Sorry, it's damage D, man. Why did I say 4? Sorry, it's damage D. Each turn we may play some cards, right? Each turn we may play some cards, as long as the total cost this turn is less than or equal to 3, right? Again, each turn we may play some cards as long as the total cost this turn is less than or equal to 3, right? So less than or equal to 3. Each turn we may play some cards, so I'll just write here, each turn we may play some cards as long as the total cost this turn less than or equal to this one, 3. This is nothing but the total cost, right? So each turn total cost less than or equal to 3. Unplayed cards are discarded. So whatever the unplayed cards that are left, they are discarded, right? So every 10th card we play, like when I say every 10th card we play, it may be 10 20 30 etc., right? So every 10th card we play here deals the double damage. This deals to what it deals here, this deals double damage, right? Every 10th card we play deals the double damage, right? So this is fine. So we have to maximize the total damage over all turns. What we need to maximize, we need to maximize total this one, damage over all turns, right? So total damage over all turns over all turns, right? So this is fine. So again, let me read the question from the beginning. So now we should be able to read this one, understand the question clearly. See, we have n turns. On the ith turn we get ki cards, nothing but the k cards, right? So each card has cost C in 1 2 3 and damage D. This one we know, right? So this is fine. Now each turn we may play some cards as long as the total cost this turn is less than or equal to 3, this part, right? So every 10th card we play, 10 20 30 40 50 etc., that deals damage, this one, double damage. Every 10th card, 10 20 30 40 50 60 70 so on, right? So we have to maximize the total damage over all terms. What we need to do here, we have to maximize the total damage over all turns. So that's what we need to do, right? So I hope this part is completely clear, man. This is the question, right? So what we need to do, we have to maximize the total damage over all the turns. That's what we need to do, right? So here we have 5 inputs here. See, 3 1 6 1 7 1 5. This is 1, this is 2, second input. So this is 3 and this is 4 this is 4, and finally this one is 5 fifth one, and the output that we need to get here is 263, right? So this is about the input output. So how we got 263, let's try to understand the same but on the this one approach. So let's see the what kind of data structure we'll be making use of, and what are the things, what are the steps that lead to this one, mainly the output. So what we will be doing inside, those kind of things we'll be discussing in the approach, right? So let's discuss the approach first, followed by the complexities, and then let's write the code. As usual, first let's discuss the approach. So here we have the example one here. The first example they have given in the this one question, the same example I have considered, so that it will be easier for us to understand, right? The input they have given here is this one with the 5 inputs basically, right? So y represents 5 inputs. We have been given 5 inputs, and the output that we need to get here is 263 over 1. So this is fine. So now let's go with the step-by-step explanation, man. So let's go with the input recap. So we are going with the turn 1, turn 2, turn 3, as well as up to turn 5 basically, right? So turn 1, turn 2, turn 3, turn 4, and turn 5, right? So because we have been given 5 here, right? So this is fine. So this side will consider 6, 7, 5, 4, 3, 0, 5, that one. So turn 1, we have 3 cards. See here, we have 3 cards, right? 6, 7, and 5. Cost 1, 6, 7, 5. Turn 2, we have 2 cards. Turn 2, we have 2 cards, 4 and 3 basically, right? So this one. And turn 3, we have 3 cards again, right? So 3 cards, this one. Turn 3, we have 3 cards again, right? So 0, 5, and 3 here. This is fine. Cost 1, which costs 10, cost 2, which costs 3, and cost 3, which costs 5 basically, right? So this is fine. And let's move on with the turn 4. We have 3 cards again. Turn 4, we have 3 cards here, right? So where is this one? This one, 15, 4, and 0 basically, right? So let me come here. So 15, 4, and 10. This one, 15, 4, and 10. Sorry, not the 0. This is fine. Here also it is 10, 3, and 5, not 0, 3, 5. This is fine. Don't get confused. So I got confused here. So this is fine. 10, 5, and 3. So finally we have turn 5. Let me come here. Cost 1. We have 1 card that is nothing but cost 1, which is equivalent to 100, right? So now let's go with the chosen place, right? So we want the 100 card to be the 10th played card, so it doubles to 200, right? So in the question they have strictly mentioned that every 10th card that we play deals the double damage, right? So every 10th card that we play deals the double damage, whether it can be 10 multiples of 10 in simple terms, right? So 10, 20, 30, 40, it goes on like that. So we want the 100 card to be the 10th played card, so it doubles to 200. So we must play exactly 9 cards before, right? So we must play exactly 9 cards before turn 5, right? So each turn's cost budget has to be less than or equal to 3. This one also they have mentioned in the question. Each turn we may play some cards as long as the total cost this turn has to be less than or equal to 3. That's what they have mentioned in the question, right? So here each turn's cost budget has to be less than or equal to 3, which forces basically that the combos are possible, right? So we pick combos that maximize the damage and also reach the 9 cards before the last turn or the 10th turn. So that's what we will be doing, right? So we pick the combos that maximize damage and also reach 9 cards before the last turn. And for this one, let me tell you, we will be making use of the dynamic programming, right? So we will be going with a dynamic programming approach. Just remember this one, right? So we'll be implementing the dynamic programming basically, right? So this is fine. So this is the exact play sequence that I wanted to show basically, right? So card index along with the damage, this one, and double. So when it comes to 10, right? So turn 1, so we will play 7. So accordingly with the this one we are playing, right? So 3, 3. So this one input man. Sorry. Turn 1, this one, play 7. So we have to go with this one. Turn 1, play 7 like that, right? So for every this one step. So turn 1 will be going with a play 7 first card. So this will be plus 7. So running will be 7, right? So card index, we are considering card index, this one, as well as the damage, this one, which is double basically, right? So turn 1, so we'll play 6. So we have 7 6 7 5, right? First three cards. So that's one itself we are considering. Basically see here 6 7 5 three cards. So next we'll be considering fourth, next we'll be going with the 10 5 3, next we'll be going with the 15 4 10, right? So finally we'll go with the 100, like that, right? So the same thing I'm just showing this one in the exact place sequence, right? 7 6 5, meaning this is shown in the descending order. Basically first 3, 7 is the highest one, highest digit, 6 5. Next we are going with a 4 3, this one 0, actually we'll be considering that one 1 0, right? So finally we'll be going with the 3 15 along with the 10. So for the first one we are going with the descending. Basically turn 1 will play a 7, first card plus 7, running 7, right? So second card we have plus 6, so when we add plus 6 to the 7 it becomes 13, right? So this is fine. Now the third card we have is 5 here, so I have given in the different order. Basically play 7, so we have just considered this one in the sequence, that's it, right? So we are considering the same 10 cards, right? So 7 6 5 4 3, this is from the input, basically the right side, if you know what I'm saying. So now we have turn 1 play 5, this is the third card, and we will be going with the play 5, this one plus 5, right? So play 5 6 7, we'll be going with the plus 5, and 13 plus 5 will lead to the 18, right? So let's go with the turn 2 now. Turn 1 we had 6 7 5, right? So we are done with the 7 6 and 5. Turn 2 we will be going with the 4 and 3 accordingly with the input. See here turn 2, this is turn 2, so let me write turn 2 here. So this is nothing but turn 1, and this one we will be considering 1 0, or not the 0 basically. This will be turn 3, and yeah, this one will be 15 4 and 10, so this one will be turn 4, and this one 100, so this one will be turn 5 basically. So let's go with the turn 2 now. So we are left with 4 3, right? So let's continue with that basically. So I'll just come here. Yeah, turn 2, first we will play 4, so this is the fourth card, and we'll be going with plus 4, right? So we had 18 previously, 18 plus 4 is running will be 22, and now we will be going with a turn 2, so we will play 3, this is the fifth card, and we will go with plus 3, play 3 we are going with here, right? So we'll go with plus 3, and 22 plus this one 3 will be 25. This is fine. So this is regarding to first 5 turns. Let's move on with the sixth one, nothing but the turn 3, right? So 4 and 3 we are done with, right? So we are done with the turn 2 basically. Now let's move on with the turn 3 basically. Turn 3, what are the numbers we have basically here? 10 5 and 3, right? So 10 5 and 3. So we will be considering here 10 0, this one and 3 basically. 5 we are done somewhere, play 5, right? So this is fine. What we will do, we will go with a play 10, play 10 first. Sixth card plus 10, so 25 plus 10 will lead to running 35, and we have already went with the play 5, so we'll ignore that one. So we'll go with the 3 again. So turn 3 will play 3, so this one will be basically, just give me, yeah, this is the 7th card, and we will be going with plus 3 basically here, right? 35 plus 3 will lead to 38 basically. Now we are done with this one, I think. Just give me a second here. We are done with turn 3 basically, right? So now we will be going with the 15 4 and 10. 10 we have already considered. We'll be going with the 15 and 4 for this one, turn 4. We have to go with 15 and 4. We have to go with 15 and 4, right? So 54 also we have considered already, I think. Yeah, 4 we have considered, only 15 we will be considering here. So this is why the DP will be handy, right? So we will not be considering this one 4 and 10 again, right? So here in this case we'll be going with the turn 4 play 15, right? So this one will be the 8th card, and play 15 will be going with the plus 15. 38 plus 15 will lead to 48 53, right? So finally we'll go with a turn 4 play 10, right? So we are left with the last one, turn 5. Within the turn 5 we will be going with only one thing we have, that is 10 basically, right? So this one we're left with 10, so we will go with before 9 turns we have to so turn 9 we have one more turn, right? Yeah, turn 9 we will be going with the play 10, so we have to ignore this one, right? 10 we have already considered. Let's consider this one as well. So we will be going with the play 10 ninth card, right? So this one will be considering plus 10 here, so this one 10, so running will be 63, 53 plus 10 here, this will lead to 63, right? So this is fine. Now let's go with the final turn. This is nothing but the turn 5, so we will play 100, right? So we'll play 100, the value we have is 100. So here 10th card, so this will be doubled, every 10th card it will get doubled, right? So this one will be instead of the 100 here, this will be 200, it will be 1, so it will be 200. So 200 plus the previous value that we got here is 63. See here, 200 plus 63, so we have to consider double plus the previous value, right? So we will be summing up the double as well as the previous value, so this one will lead to 63 plus 200, 263, right? So this will be our output, this will be our output, right? So just give me a second, 1 second. So this will be our output basically, so 263 will be our output in simple terms, right? So what we will be doing in simple terms when it comes to coding terms, so we will be making use of the DP over turns storing remainder, nothing but I equals total cards that is played along with the mod 10, right? So for each turn we will try all useful combinations, nothing but cost less than or equal to 3 accordingly with the question, and we will we will add the sum of chosen damages, and we will add the maximum chosen damage once if a 10th card falls. This one 10th card falls inside the chosen block, right? So because we can order cards arbitrarily inside the turn, so that's what they have given in the question, and the provided basically we'll be writing the code using the DP basically. Let's see that one later. For now the approach will be the same, whatever I have explained in the whatever we discussed in the approach, this one approach remains same. So the output that we got here is 263, which is equivalent to the output that they have mentioned for the example 1 within the question, right? Example 1 within the question, right? So our approach works absolutely correct in this case. So as our approach works absolutely correct, now we can discuss the complexities part. So what will be our time complexity here? So the time complexity would be big O of sigma ki, or the k log k plus 10 into n, right? So why it is sigma this one k log k plus 10 into n here? So 1 second. So we don't have to go with this one, I think. So this is sigma k into log k is for the sorting basically. 10 into n is not required. 10 into n because so I had considered this one because this one, what do we call, every 10 gets doubled, right? So for the 10th step it gets doubled, right? So double damage, it deals to the it deals with double damage, so that is the reason I consider 10 into n. So here it would be because sigma ki into log ki for the sorting card groups, right, across the turns. So it is equivalent to the big of m log m, where m is nothing but the total cards, plus big of 10 into n, right? So DP updates here, so we can consider 10 into n. So let me write 10 into n itself, so this is fine. Plus big of 10 into n DP updates. Overall it would lead to big of m log m plus n basically in simple terms also, or we can consider this one in the mathematical term. So let's go with the simple this one, because the overall time complexity would be big of m log m plus n, right? So what would be the space complexity here? So space complexity would lead to big of n into 10 plus max group size, which is equivalent to almost this one, big of n plus m. So let's consider this one n plus m rather than the big of n into 10 plus max group size, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big of m into log m plus n and big of n plus m respectively, right? As we are completely familiar with the time complexities or the complexities part, we are good to write the code, right? So we are completely familiar with the approach and the complexities part, so we are good to write the code. Let's start writing the code. So let's start writing the code. Now I'll just come here. So we need we'll be making use of the fast input output, so let me go with this one. Let me try to import the input output package. I'll just go with start. This is fine. Next, let's import the utility package as well, as we'll be making use of different utilities, right? So this is fine. Now let me go with public class main, right? So within the main class, what we'll be doing first, we'll be going with the unused modulo constant, right? So this is nothing but the typical template placeholder man. Just the value that I'll be mentioning here, 10 to the power of 9 plus 7. So this one will be int modulo. I'll just consider m here. So this one has to be 8 zeros I have to give, right? 6, 7, 8, 10 to the power of 9 plus 7. This is fine. Now I'll be going with the base n that is used to size dp, right? So this is nothing but the safety margin, just remember this. So I'll just go with static. So again the same thing, final int, instead of m I'll just give n here. So this one will be 1 followed by 5 zeros plus 10. This is fine. Now let's do one thing. We'll be making use of the dpr as I've said, the approach, right? So let me go with long here, dp equals new. So I have made use of the long, right? So I have to use long here. So this one will be n into 2 plus 20 I'll go with. So this is fine. Now next I'll make use of the solve helper method. Basically what we'll be doing in the solve method, so this does the main dp processing, right? So it receives a tokenizer for the input and the output writer, right? So we will be making use of we'll be going with the main dp processing with the solve method, and it receives a tokenizer for the input and the output writer. Just remember this one, right? So let's go with the solve method. Let's write that one very quickly. So I'll just go with the static void, this one will be solve, right? So this is fine. So within this one, let me pass string tokenizer here, st, as well as print writer, so output. So within this method, first we have to go with the number of turns, right? Nothing but n. So here this will be t. Let me assign this one to the integer. First integer dot pass n. So this is the input part, man. First in our case it was given 7, I think. The first example consisted of this one 5 basically. So this is fine. Parcent, it is of the type integer, right? So this one will be string tokenizer dot next token. This is also fine. T is nothing but the number of turns n here, right? So we have to initialize the dp for 0 turns, meaning we have to set the impossible states to negative infinity, right? So dp of 0 0 will be equivalent to the 0. So I'll just go with the for loop here. So this one will be int I equals 0, I less than 10. Let me increment I here. So dp of 0 1, so this one not 1 basically, I, sorry, dp of 0 I, this one, let's go with long. We have to convert this one to the long, and the value I'll just give here 1e18, right? So this one is negative 1e18 I have given because it is impossible sentinel, right? So this is fine. Now let me set the dp of 0 0 to the 0. So this is just nothing but when 0 damage is caused, right? So when we have played 0 cards, 0 damage is dealt initially. So we are going with dp of 0 0. We are assigning this one to, or initializing this one to the value 0. This is fine. Now let's iterate through the turns from 1 to t, right? So let's go with the for loop here. So this one will be int x equals 1, x less than or equal to t. Let me increment x here. So within this for loop, let's go with the number of chords in this particular term, nothing but ki or the k, right? So I'll just go with int n equals let me copy this one. Same thing, it's integer, right? So this is integer dot passant string tokenizer dot next token. So this is nothing but the number of chords in the turn. Okay, so now we have to go with a p1, p2, p3, which will store the damage values of the cards grouped by the cost 1, 2, 3 accordingly with the question, right? So let me consider list. So this one is of the type integer, right? So now array, I have to mention array p equals new array list. I'll just pass 4 here, right? So index from 1 to 3 we have to consider. So let me pass 4 here. Now let me go with the simple for loop here. This is int I equals 1. I we have already considered. Yeah, I have to consider from I this one 1 to 3 we have to consider, right? I less than or equal to 3 and I plus plus. So let me set the p of I equals new array list. This is fine. Now we are done with this part, man. So now what we need to do, we have to read the n cards for this particular turn and place their damages into the corresponding cost list. So that's what we need to do. So let's try to implement the same thing in the form of code. So this one will be int I equals 1. Yeah, I less than or equal to n. So this one will be I plus plus. So within this for loop, let's go with the cost cj, nothing but from 1 to 3. So this one has to be int a equals integer dot %. So just give me a second here. Yeah, this is fine. Integer dot %. So let me copy the same thing. I had copied the same thing, right? So let me paste it over here. Same thing, int b equals integer dot %. Same thing, string tokenizer dot next token. This is nothing but the damage dj, right? So now we have to push the damage into the p of cost. So I'll just add p of a here dot add of you have to just add b, right? So b, yes, this is fine now. Now let's do one thing. Let's sort each p of I in the descending order. So top elements are the highest damages. So let me go with the for loop here. So int I equals 1, I less than or equal to 3. So this one will be I plus plus. This is fine. P of I dot sort. We have to sort, right? So this one will be a comma b lambda. So this one will be b minus a, right? So we are sorting in the descending as I had said during the approach, right? So for the first one, so now by default we have to go with the carry over previous dp values, nothing but the we are going with the option playing the 0 cards, right, for the particular turn, right? So I'll just go with the for loop here, and j equals 0, j less than 10. So this one will be j plus plus. So dp of xj. So this one will lead to dp of x minus 1 into j. So this is fine, man. But so we have went with a 2 for loop. This is fine. Now next what we will be doing, let's consider playing up to 3 cost minus 1 cards, nothing but 1 plus 1 plus 1 we have to go with, right? So which is equivalent to the 3. So now this we have to write for the 3 man, all the 3 turns, right? So this is somewhat not tricky, basically this is somewhat lengthier in simple terms. Just give me a second here. Where did I stop here? 2 for loops we have considered, right? So let's consider playing up to the 3 cards now. So first if condition here will be if not of p of 1 if it is not empty, right? So this one if it is not empty, Then what we need to do, let's go with the for loop. This one int j equals 0, j less than 10, j plus plus. So this is also fine. So within the for loop, so if we play 3 cards of cost 1, meaning it requires at least 3 such cards, right? So again, let's write the simple if condition within the for loop. So this has to be if p of 1 dot size, if it is greater than or equal to 3, then I can just write it here, dp of x, sorry, dp of x j plus 3 modulo 10, right? So this one, did I miss anything here? X, so let me do one thing, let me add this one more this square bracket here. So this one equal to math dot max dp of x along with the this one, what do we call, j plus 3 modulo 10. This is fine. Now let's go with dp of x minus 1 j plus p of 1 this one dot get of 0, so fine, plus p of 1, this one dot get of 1, this is also fine, plus p of 1 dot get of 2, so this is also fine, plus this one will be, one second, j less than sorry, it has to be greater than or equal to 7, yes, then it will be p of 1 dot get of 0 here, else we have to display 0. This is fine. So I messed up the bracket somewhere, I don't know where I messed up, but I messed up the bracket somewhere. This one will be dp of j plus p of 1 dot get of 0, this is fine, plus p of 1 dot get of 1, this is also fine, plus p of 1 dot get of plus j greater than or equal to 7, this is also fine, p of 1 dot get 0, j, this one is fine, greater, j is greater than or equal to 7, then we are printing p of 1 and we are getting the value p of 1 dot get of 0, this is also fine. So did I mention this one? I have opened here, I'm not closed anywhere, so let me consider one more parenthesis here. It's fine. Now what we need to do, what if we play 2 cards of cost 1, right? So this one has to be 1 plus 1, that is equivalent to 2, right? So for that, let's write the code again, one more if condition here. So if p of 1, so this one dot size greater than or equal to 2, then what we're gonna do, dp of x, so this one will be j plus 2, this one modulo 10, so this is equivalent to math dot max dp of x, again j plus 2 j plus 2 modulo 10, this is also fine, comma dp of x minus 1 j, this is also fine, plus p of 1, this is also fine, get of 0 dot get of 0, again plus p of 1 dot get of 1, So this is also fine. Plus j greater than or equivalent to 8 if it is so here if it is, then we have to go with p of 1 dot get of 0, else we have to display 0, right? So again this is fine, man. Now this is fine. Now we went with playing 3 cards and we went with playing 2 cards. If we play 3 cards, we went with 1 plus 1 plus 1 3. This step we went with playing 2 cards. Now what if we play 1 card of cost 1? That one also we have to consider, right? So for that one also we have to consider again. So this one will be dp of x. So the same thing, let me consider the same thing here. We copy the same thing and make the necessary changes over here. I don't want to type this one again. So this one will be dp of x. J, instead of j plus 2 we are only playing 1 card, so this will be j plus 1 modulo 10. This is equal to math.max of dp of x. Instead of j plus 2, this one will be j plus 1. Right, j plus 1, this one will be modulo 10 comma dp of x minus 1 into j, this is fine, plus p of 1 dot get of 0, this remains same. Get of 0 plus, so this one has to be, this one we need to change, basically we don't need this one, plus j less than or equal to, instead of 8 we are just playing 1 card, so this one has to be j greater than or equal to 9. If it is j greater than or equal to 9, then p of 1 dot get of 0 we have to display, else 0. This is fine, man. This is same, right? So I'll just come out of this one entirely. Now we have to consider the playing cost 2 cards, right? Each cost 2, meaning we can play at most one such card alone, cost 2, or with a cost 1 card to sum 3. So these things we have to do. Again we have to go with the same this thing, what do we call, steps, basically, right? So this one, let me write the simple if condition. If here, if not of p p of 2, basically cost 2 we are going, right? So this one is empty here. This is fine. Now within this if condition, let me go with the for loop here. This one will be int j equals 0, j less than 10. So let me go with j plus plus. So this is fine. So within this for loop, so first we will be playing the single cost 2 card. So let me go with, let me paste this one, previously whatever I have pasted, I'll make the necessary changes over here. So this one will be dp of x, instead of j plus 2, this will be j plus 1 modulo 10 equals math.max of dp of x, instead of j plus 2, this one will be dp of x j plus 1 modulo 10 dp of x minus 1 into j. So this remains same, plus instead of p of 1 we are going with the cost 2, this one will be p2 dot get of 0 plus we don't need this one, just give me a second here, we don't need this one. If j greater than or equal to 9, then we have to go with p2, right? Here instead of p1 we have to go with p2 dot get of 0, else we have to display again 0, the same thing, right? The same thing. So now we are done with this part. Let me do one thing, let me come out of this one. So what if we play one cost 2 plus one cost 1, meaning if p of 1 exists, then total cost has to be 2 plus 1, that is equivalent to 3, meaning 2 cards are being played here. right? So for that one also we have to write the this one. Again the same thing, we have to implement the same thing in the form of code. So this one has to be if not of p of 3 instead of 2 dot is empty. So again let me write the for loop here. This one for int j equals 0, j less than 10, so j plus plus, right? So this is fine. So within the for loop, let me copy paste the same thing here and make the necessary changes. This one again. So this time when two cards are being played, if the 10th one falls inside them, meaning if j greater than or equivalent to 8, right? So then we can pick which of the two gets doubled, right? So meaning we have to choose the larger damage, or we will be choosing the larger damage. So this time we'll be going with dp of x, this one j plus 2 remains this one same modulo 10. So math.max j this one x j plus 2 this one modulo 10 this remains same, comma dp of x minus 1 j plus this one instead of p of 1 we have to go with p of 2, right? So we are going with a as we are dealing with a cost 2 basically, dot get of 0 plus this time we have to keep this one, right? So this one instead of again p of 2 dot get of p of 2 sorry dot get of 0 we have given, right? So p of 2 dot get of 0 plus p of 1 dot get of 0, 1 dot get of 0 here, right? So this is fine. Finally if j is greater than or equal to 8, then what we will do, we have to go with, instead of this one, let me write here, we have to go with math.max of p of 1 dot get of 0 here, comma p of 2 here dot get of 0, this is also fine. Else we have to display 0. This is fine, man. We are done with this part basically now. Right, so let me come out of this one entirely. So just give me a second here. Let me come out of this one entirely. Now we have to consider cost 3 cards. This is going to be the last. So we have to consider cost 3 cards, meaning a single card with cost 3, right? So it is one card that is being played, right? So now again one more if condition here, right? So if here not of p of 3, if it is not empty, basically I'll just make use of is empty again. This is fine. Now let me go with the for loop again. So this one int j equals 0, j less than 10, so j plus plus. So within this for loop, let me paste the same thing over here and make the necessary changes, right? So this time we are considering cost 3 cards, meaning single card with cost 3, right? It is one card that is being played here. So dp of x instead of, it is one card that is being played here, so this will be j plus 1 modulo 10. Again this one will be j plus 1. This is fine, modulo 10, so this is fine. J plus 1, this one modulo 10, this one has to be array, man. X j plus 1. Oh, this one I have to remove here. Here I have to close. So everywhere I have to do the same thing now. Just give me a second, 1 second. I have to remove this one and go with here. Again have to remove this one. Everywhere I have copy pasted the same thing here. So let me change this one or else we'll get the error later. So this one we make this one array. Let me remove this array as well. So do I need to change anywhere? No, right? J plus 3 again here as well. So this is fine, I believe. So this is after sorting, right? So just give me a second, 1 second here. So we are sorting each p of I in the descending order, so top elements are the highest damages. So this one we have done, this is fine. P1 node size, this one has to be, yeah, so this is fine. Now let's come to the final one, man. So here, if dp of xj plus 1 modulo 10 is equal to max of dp of x, also dp of x j plus 1 modulo 10 comma dp of x minus 1 j plus p of 1, this is also fine, 1 j plus instead of we are going with a 3, right? So this time it has to be p of 3 here, p of 3 dot get of 0, this is fine, plus this one we don't need, man, plus j greater than or equal to 9, right? If it is, then we will be going with a p of 3 here. P of 3 dot get of 0, right? Else we'll be going with a 0. This is fine. Now we are done with this part. After all the turns, we have to find the maximum among dp of t to 0 to 9, so the best achievable damage. So I'll just go with long t max equals 0. This is fine. Let me go with a simple for loop here. Int I equals 0, I less than 10, so this one will be I plus plus. So this one will be math dot max of t max comma dp of t and I. So this is fine. So we are done with this part. Finally we have to go with out dot print ln of this one t max. So we are just printing the answer here, right? So we are done with this part. Now let's go with the main method, right? So along with the input output we have to deal with certain things, right? So just give me a second. We are done with almost most of the things here. We have went with the solve method, right? So we are left with only input output part, I believe. Yep. We are left with only input output part. Basically I'll just copy paste this one, man, as we are dealing with only the input output part. The logical part is done here. Whatever we had discussed in this one approach that we have implemented here, the same thing again and again. So because of this one, only the 3 criteria that we have to go with, right? So that is the reason I had copy pasted and made the necessary changes for every this one, p of 1, p of 2, as well as for the p of 3, right? So the same thing. So now let me copy paste the this one input output template. Just give me a second here. So let me come here, let me paste this one. This is purely related to the input output template, so you can just go through this one if you want to use the same this one template, or you can just make use of a different template as well, right? So this is fine, I believe, right? So now one thing I want to tell you here is we are making use of the solve within the main method here, right? So we are just running the solve with the tokenizer in the output writer here. This part I wanted to mention, right? So this is the only thing. All other things are related to the pure input output, right? So again, whatever the solve method we have written here, this one we are making use of it within the main method. We are calling this one within the main function of the main method here. Mainly we are running the solve with the tokenizer in the output writer here. Just remember this one, right? So this is fine. So we are done with the coding part. Before running the code with the different this one input before checking the code with different inputs, let me copy paste the signature starter template. Just let me give here this is fine. Let me come here, let me copy this one. The output that I need to get here is 263. Let's check one. Let's check this one. So here I have given, this has to be capital I, so line number 34. So let me give capital I here. Let me run this one again. So yeah, we are getting the output 263, right? So ignore the warning. So we are getting the correct output, meaning the code was absolutely correct, right? So let me copy this one entire code. So I just come here, let me hit the submit button here. So we have come to the submission part here. So let me paste the code here and hit the submit button. So let's wait for some time. I hope this works for all the test cases. Let's see. Only we have to consider only the three criteria. So whatever the not of P1, P2 and P3 that I had written, right? So these along with the cost basically. So we are having the runtime error on test 2. So let's check what we have done wrong here. Just give me a second. So what mistake I have done here is we are going with the cost 2 plus cost 1, right? So here I have considered cost 2 P of 2 along with the P of 3. The cost 3 we are not considering at all here. So we have to go with the cost 2 along with the cost 1. So I'll just keep P of 1. So now if I run this one, this has to work correct. Let's see. Let me copy this one entirely. Again, let me come here. Basically, just give me a second. Yep. Let me paste the code over here and let me hit the submit button. So this time this has to work. Let's see. I cannot say anything about it. So let's wait for some time, man. So yeah, here you can clearly see here, man. In the toast it is showing accepted. This one, whatever you call, the verdict that we got here is accepted as well. So we have made use of the pure DP here, man. Complete pure DP we have made use of here, right? Just to solve this particular problem, right? I hope the solution part is completely clear. This is kind of headache. This is the difficult question, man. You have to read the, you have to go through the question correctly. All you have to do is here. So you have to know some of the things, right? You have to know some of the things, right? Along with how to make use of the DP here, mainly how to make use of the DP, right? So that is the main thing here. So this is it for the particular, this is it for the solution part, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.